Good afternoon, everybody. Welcome to really cold, sunny afternoon at Chem 170 Organic Chemistry with your host, Dr. White. As I sent out an email, and now I'm going to look. I can't believe I did it. I had a setting wrong, and on Monday's lecture, I didn't record it properly. Well, I changed that, so everything should be right. But I sent out an email, and you can go back and look at previous first day Chem 170. It's essentially the same, even some of the same bad jokes, but I'm recording good right now. Now, let me remind you, in my class, in my world, there's no such thing as a dumb question. I'll say it again. In my class, in my world, there's no such thing as a dumb question. So always feel free to ask questions. On Zoom like this, you can turn your microphone on and ask a question, or you can use the bottom here of the screen, which I can see, the chat. Now, once in a while when I'm lecturing, I don't look as often to the chat, so it may take a second or two or more before I notice, oh, somebody's got a question. But turn your mic on and do that. That's probably the best way. All right, let's talk about Wednesdays. Ooh, today is Wednesday. Uh-oh, it's Bad Humor Wednesday. But anyways, on Wednesdays, normally, I will lecture for 50 minutes. Then we take a 5-minute break. I like those special effects I have. I said it was Bad Humor Wednesday. It is. And then we do the lab. However, the way we have it set up, if we're at ECC, today we would be checking in. But we're not checking in because you're not in the lab. So because I also missed time when we started late, today I'm going to spend all Wednesday lecturing like I did on Monday. But starting next week, I will be lecturing, then we'll do the lab. And hi there, I better pin myself. There, I'm pinned. So that's today's game plan. All right, let's get started. And let me just close something real quick. All right. On Monday, when we left off, I started going through the Iupac nomenclature rules. Now, nomenclature rules are not the most exciting thing in organic chemistry. I'm going to be honest with you. For those of you who've seen the Blues Brothers movie, I don't know if there's more than one, but the original one, where they go in, one of them in a fancy restaurant orders 4 pieces of dry white toast. Yeah, it'll keep you alive, but there's more exciting things. Iupac nomenclature and knowing how to name compounds is very important. There's more exciting stuff I'll get into, but it's still very important, which is why I'm covering it. Now, I talked about this chart on Monday. And as you found out on Monday, let me readjust my pad here. That's my phone. I will not answer it. In 2 more rings, my answering machine will answer it. 1 more. Stop. It stopped. All right, you should know. Uh-oh, I counted wrong. Now stop. You should know this. And what do I mean by that? You should know methane, the Iupac name, is for 1 carbon. Propane, everybody remember propane from Monday? That's 3 carbons. Hexane 6, octane 8, decane 10. And as I showed you on Monday, if you write it down and say it 5 times, methane 1, and actually write it down and say it and look at your piece of paper, do that 5 times. It's going to be burning your head if you do it twice. You need to know this. If you do not know this chart before test 1, you'll lose 50 points out of 100. That's not good. And test 2, about 40 points. Test 3, 40 points. And about 40% of the points on the final, 35 to 40%. So it's important you start learning this. You're not going to learn this a day or two before the test. Trust me, I'm a chemist. Did that work? How about I'm an organic chemist? How about I'm a doctor? All right. Now, we're talking about Iupac nomenclature rules. So let's practice. And this is being recorded, so I will be posting this sometime today or tomorrow on the YouTube channel for Chem 170, mine. All right, question is, give the Iupac name for the following molecule. Well, what do? You have to find what's the longest carbon chain. And there's no other way than start counting. I don't know of a better way. So on this example, if we count across, we have 9 carbons. Now, if I go to another color, 1, 2, 3. Remember, longest chain means they're connected together by a bond, and this carbon is connected to this one, so that'd be 4. Connected, that's 5. There's one more chain. If I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, one of the beauties of Iupac, and in my mind, what they did was astounding, the rules they came up with, and still evolve and modify when there's a problem, but there really hasn't been. If you do it correctly, any molecule only has one Iupac name. Again, if you do it correctly, any molecule only has one name. Now, if you notice in blue and red, they're both 9 carbons. So it doesn't matter which chain I pick, I'll get the same one. So what I'm going to do is pick, I'm not going to do the green because that's only 5. And the blue, I'm going to take off, but I'll show you in a little while. Either way would have given me the same answer. And my longest chain is this. Now I'm putting in the numbers and circling so you can see what I'm talking about. On a test, you don't have to do that. If you want to, go right ahead. But, so what's the name of a straight chain 9 carbon alkane? Well, you memorize this chart, hint, and you come down here, 9 carbons is no name. So that means our root name is no name. And as soon as I put that down, all this in the red circle, or I don't know if that's really a circle, I guess ellipse or whatever, I'll call it a circle for now, is taken care of. Am I done? No, this is left over. What is this? This is an alkyl group called a substituent. And how many carbons are there? 2. So let's look at the other table, which you should start memorizing, and that's the alkyl groups. And there are many alkyl groups, but for most of what you'll ever encounter in your life, and most of what I've done work with, these are the key ones. Notice here, CH3, CH2 connect to something. That's what the line means, is ethyl. So CH3, CH2 connect to something is an ethyl group. This chart and the chart of the alkane straight chain names are in the lecture folder of D2L, both as a Word document and a PDF document. So I now know the alkyl group, what's left over, is called an ethyl group. So I can go back here, and in front of my root name, I put ethyl. Let me get back to black. Now, am I done? No. You have to now tell which carbon on your longest chain, the one circled in red, is that ethyl group on, just like the address of your house, condo, or apartment. And you do that by numbering the chain from each end. Common mistakes students make: oh, it's on this carbon, I'll call that 1. Wrong. Please don't do that. I'm telling you that it's a mistake, so you don't do it. So how do you find out what's the location? You start from each end and you number of the longest chain. Now, if we look at this carbon right here, if I start from this end, it's on carbon 3. If I start from this end, oh, by the way, I don't know if I mentioned this. Back in high school, I had a German teacher, Herr Brink. I still remember. He was really good. I can still picture him. That was back in about, oh, I hate to say this, but I will. I'll give away my age. That was back, I think, in 1966. Boy, I shouldn't have said that. But anyways, and he wrote, he was from Germany, and this is the European way of writing, or German way, Dutch too, of writing a 7. I thought that was the coolest thing in the world, and I still do it. It is the coolest thing. But anyways, this is on carbon 7. So you, for the Iupac rules, you give the alkyl groups, the stuff that's not on that's attached to the main chain, the smallest numbers. In this case, I hope you all know 3 is smaller than 7. So that's 3-ethyl nonane. And that's how you do it. Let's go through what I did. I found the longest chain of continuous carbons, and that was 9. And if you notice, I had to count all the possibilities. I know of no easy way other than doing it that way. Next, what's left over, in this case, one of them is called an alkyl group, and you have to name it. So the base name, 9 carbons from that table, no name. Next, the alkyl group, 2 carbons, in this case, ethyl. Next, you have to, what carbon is it on? And there you number from either this side or this side. You can only start for a acyclic, that means not in a ring, chain, from either end, never any other place. That's a common mistake. Don't do it. You'll get it wrong. I don't like marking things wrong in a test. It doesn't give me any joy. I do, but not. And that's on carbon 3. All right, let's do another one. All right. First, let me put in the hydrogens. Remember, I'm doing that because there's 4 bonds to carbon. Remember, four bonds to carbon. And T-chain, there's a thing called fading prompts. I'm going to do fading prompts on you right now. That molecule, what I'd like you to do on your own right now is, what's the longest chain? Your turn to have fun. By the way, if I say fun enough, you'll believe me. And if any of you other people would like to turn on your webcam, please do. And those of you who do have it on, thank you. All I'm asking you to do at this point is, what's the longest chain? Because eventually we'll do the Iupac name, but just the longest chain. When you're done with that, give me a thumbs up, either on your screen or use the emoji. If we were in a classroom, I could look and see everybody's done. And I'd also say, when you're done, look up and smile. And people actually do smile in my class. It's fun. All right, let's get the word. What's the longest chain? Well, if I count across, 1, 2, 3, 4, 5. But there's another chain. 1, 2, 3, 4, 5. They're the same. So you got to check which way is the longest, and it doesn't always have to be straight across. Now, in this case, I'm going to do straight across again. Here's my longest chain. And either way, I'll show you. I didn't do it the last example. You get the same answer. So 5 carbons. What do we call a 5-carbon chain? Well, once you learn this chart, hint, 5 carbons is what? Pentane. So the root name is pentane. Remember, if you're not getting this, do not feel afraid to ask questions. That's why you're here, to learn. So my longest chain is pentane. Now, one bad habit Dr. White me has is when I'm writing some of these, looks like some are capital and some are lowercase. If you're keyboarding them, like typing them, I use the old term, even though nobody types anymore. I don't even own a typewriter anymore. They should be all lowercase. If you're typing it or writing it, I don't care which case you make it or combination. So this is spoken for. Now, are we done? No. What's left over is this. And it's 2 carbons. It's an alkyl group. That's what we call those left over. And what's 2 carbons? Well, we just did it, but let's go back. From the alkyl group, 2 carbons is ethyl. So I now know that's an ethyl group. By the way, I didn't write it here, but I'll do this right now because it's Subtle Wednesday. Everybody get the message? I can be subtle. And how do you learn this chart? Write down CH3 and the word methyl. Look at it on the paper and say CH3 methyl. Then do it again, CH3 methyl. Do it 5 times, come back a day or 2 later, repeat. That will be in your head. And from what students tell me, and also for me personally, it works better than flashcards. But if flashcards help you, guess what? Use them. But this is better. So we now know we have an ethyl group. And what carbon is it on? Well, you number from the N. I go this way. Oh, look, it's both ways. It's on carbon 3. Now, between numbers and letters, you put a dash. And that would be 3-ethyl pentane. Now, one of the things let me first review again. We found the longest chain, and it's 5 carbons. We looked at the table and found 5 carbon Iupac name is pentane. Next, what's left over? The alkyl group. We looked at the table, and that's ethyl group. And then what carbon is the ethyl group on? We number from the ends, and the number that's the lowest is the number we use here. So it's 3-ethyl pentane. Now, one of the things I didn't do last time, but I can do now, and this is the beauty of Iupac. And if I say this is the longest chain, that's also 5 carbons pentane. And a chain doesn't have to be straight, just like if you had a bicycle chain, you can move it all around. Now, what's left over? And this is really how they did an amazing job. An ethyl group. And what carbon is it on? Carbon 3. So I start this way, 1, 2, 3. And either way you look at that molecule, the name is 3-ethyl pentane. And that's the beauty of Iupac. If you do it correctly, any molecule only has one name. Don't write this down yet. We'll come back to this. I just realized, remember the 20-second rule. Hang on. Let's come down here and I'll come back to that. All right, what would be the Iupac name for the following? First, what's the longest chain? Time's up. 4. And since you haven't maybe memorized it, what do we call 4 carbons?
Butane.
Thank you. So this has 4 carbons, 1, 2, 3, 4. This is butane. Do I have anything left over? No, I'm done. So it doesn't have to, you don't have to draw it straight across. Normally, most chemists would have drawn it this way. And it turns out carbon-carbon single bonds can rotate. So either one of those structures is correct, even though this is easier for most of us to see, and usually the way you draw it. Now, let's do this one. Don't give out the answer, but first I'm going to ask you, what's the longest chain? Oh, I'm really working you hard today. It's good for your grade. All right, I'm going to assume everybody has had time to find the longest chain. Let's find out. Well, if I look across, it's 1, 2, 3, 4. That's one chain. Next, 1. This carbon is bonded to that 1, 2, 3, 4, 5. That's the second chain. But wait, we're not done. 1, 2, 3, 4, 5, 6. So what's the longest chain? Hopefully all know what numbers are longer and smaller, larger and smaller from 1 to 10. Hopefully all pick 6. So the longest chain is this. And that's 6 carbons. And if we go and look at the table that I hope the next couple of days you're going to start memorizing, hint, 6 carbons is hexane. By the way, I know this chart and more of them, like I know my first name. By the way, I do know my first name. And you should know that table just like you as quickly as you know your first name. So 6 carbons is hexane. Next, am I done? No, there's something left over. That's this right here. Now, let me clean this up a little. You'll understand why. And what's left over, CH3, is an alkyl group. Which alkyl group? Well, that's soon to be your good friend, the methyl group. CH3 is methyl. And hopefully this weekend, you'll start learning this chart. So I now know I have a methyl group. And that your alkyl groups go in front of your root name. Are we done? No. What carbon is it on? So we start from the end. This is one end. This is the other. I'll go 1, 2, 3 in blue. If I start this way, it's 1, 2, 3, 4. Notice I started at the ends of my chain, not here, which students try to do, and it's wrong. Now, which is smaller, 3 or 4? And time's up. Hopefully I'll pick 3. So that methyl group is on carbon 3. That'd be 3-methyl hexane. Everybody with me so far? Any questions? And if we were in a classroom, you'd watch me putting in my hydrogens. Aren't you glad I mastered a tablet that allows me to do this? Just like if I were in a classroom. Same question, and I'm going to do this one. What's the Iupac name for the following? And let me change something. I apologize. This will keep us away from what I call a gray area. I don't want to get into those now. And on my test, I don't either. All right. So first of all, we have to find the longest chain. And the only way I know is start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I'm not going to draw in the numbers, but I'll do it in blue. This carbon, this carbon, this carbon, that would be 3. and 3 is definitely smaller than 10, so I'm going to ignore it. And let me do again in blue. I could do this carbon, 2, 3, 4, 5, 6. And 6 is definitely smaller than 10, so I can ignore it. There's one more chain. I have to consider. I'll do green. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think you all know 9 is smaller than 10. So the longest chain is 10. And that chain is this. And now, if I look at the table for Iupac names of alkanes, 10 is decane, right here. So my root name is decane. Am I done? No. I have this alkyl group and this one. Now, one carbon, as we've done, is methyl. 2 carbons is ethyl. And now Iupac has an alphabet rule. I've done number 2. You find the longest alkane, the root name for the continuous chain. When we have branches, when you have alkyl group, that's called branches. Just like if you have a tree, you have the trunk, then coming off it, you have branches. Well, that's how they came up, I think, with this stuff. Now, group attached to the main chain are substituents. They're different types, and one is alkyl groups. Here's one way of getting the name. The easier way is the table I gave you. I've done this. The main chain is numbered in such a way that the first substituent encountered along the chain receives the lowest possible number. Now, each substituent, in our case for this class, the alkyl group, is located by its name and the number which it's attached to. I'll get to this 2 identical in a second. I'll come back to that. If 2 or more different types of substituents are present, they're listed alphabetically. I will not hold you to that. And therefore, don't worry about that, but I will hold myself to that. So on a test, there'll be more than one answer. When I go through the test, I'll show you the correct Iupac way, but if you switch the order, because you're not following the alphabet, and I'll show you that in a second, and punctuation is important. For Iupac names, hydrocarbons are written as one word, which I've done. Numbers are separated from each other by commas. I'll show you that in a little while. And numbers are separated from letters by hyphens. All right, and I'm not going to worry about spaces in between because you're not doing this for a journal article. All right, so we have ethyl, and it gets alphabetical priority, which you won't be held to, but I will. So I'll put the ethyl here, and then the methyl here. Now I have to find what carbon it is on. Now, if I start from this end, it's on carbon 2 and 4. If I start from this end, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's on carbons 7 and 9. Which is smaller, 2 and 4 or 7 and 9? Time's up. Hopefully you pick 2 and 4. Now the ethyl group is on carbon 4, so that's 4-ethyl. And the methyl group, CH3, is on carbon 2, so it's 2-methyl. So say that 5 times quickly. No, you don't have to. And that's 4-ethyl 2-methyl decane. Now, listen carefully. This is the correct Iupac way of doing it. On my test, don't tell the Iupac, please, okay? Shh. If you were to write that, I would give you full credit. Why? Because I'm not holding you to the alphabetical order. But if I did that, I'd be getting in trouble. Well, in other words, I wouldn't. So again, find the longest chain. What's left over are the alkyl groups. You name them, you number them, and you put them in front. All right, let's look at this one. The longest chain, the way I wrote it, and it's correct, is 6. And there are 2 ways I can do it. I'll do the easier way. This is the longest chain. And notice it's 6 carbons. Oh, by the way, tonight at midnight, I'll be giving speed writing lessons for structures. No, I won't. All right, I'll come back to this. So if you haven't finished writing it, 6 carbons, hopefully you'll learn this table soon, real soon, is hexane. So the root name is hexane. Now, what am I done? No, there's something left over. This and this. Oh, they're both the same. And soon to be your good friend, the methyl group. CH3 is methyl group. The other table I'd highly recommend you start memorizing is the alkyl groups, also known as substituents. And here, 1 carbon CH3 attached to something, that's what that line means, is a methyl group. Oh, we've got 2 methyl groups, not 1, but 2. Well, how do we deal with that? If 2 or more of the substituents are accept prefixes as di and tri, oh, that's, I got ahead of myself. Oh, where are you? Here we are. Prefixes, that means in front of a name, such as di and tri, I've never used tetra, are used when 2 or more identical groups are attached to the main chain. So what does that mean? When you have 2 or more of an identical group like methyl, use di, tri. I've never used tetra. Di and tri are more often. So let me do this. And this is something you need to know. I'll do it in black. And as I mentioned, there's a lot of memorization in organic chemistry. I'm not going to sugarcoat it. So we have 2 methyl groups, and that's di methyl. The methyl tells me CH3. The di tells me there are two of them. If it was tri, there are three of them. Now, one of the important things about Iupac names, you never have to guess. If I have two methyl groups, di, I need two numbers. I'll say that again. If I have two methyl groups, which di tells me that, I need two numbers. And you do the same thing, even if they're the same group, you number from each side. And notice if you number from the left, it's on carbons 2 and 3. You start from the right, it's on carbons 4 and 5. Which numbers are smaller? Time's up. Hopefully all pick 2 and 3. And how do you show that? Two numbers are separated by a comma, 3, and numbers and letters are separated by a hyphen. It says 2,3-dimethylhexane. Let me go through that again. You find the longest chain, which we determined was 6. And if you don't believe me, go back and check later on. And then what's left over? 2 CH3 groups. CH3 is a methyl. And what carbons are they on? Carbons 2 and 3 of my longest chain. And that's how you do it. It's time for you to try one. And there you go. Why don't you try this one? You know what a CH3 group is, methyl, and the longest chain, I'll give it away. Oh, I'll give you another 22.7 seconds to figure it out. What's the longest chain? It's 3 carbons. 3 carbons, the root name is propane. Your turn to have fun. And if you finish early, I try to give everybody time to finish. And when you're done, give me a thumbs up. Thank you. And if you're having trouble with this, don't worry. When you're new at something, it isn't always that easy. And don't forget, tonight from 5 to 6:15 on the different Zoom login for my office hour, I'll have my office hour in 15 minutes. And if you have any questions that you don't want to ask in front of the group, feel free to stop by. Again, give me a thumbs up when you're done. This one might be a little tricky. All right, let's try this. What's the longest chain? 1, 2, 3. I could have gone many different ways from here to here to here, or here to here to here. They're all going to be 3. So I'm going to do the easy thing and do this. Say my longest chain is propane. What's left over? Oh, Dr. White's going Technicolor on you. This and this. And that's your old friend, soon to be old friend, the methyl group. How many are there? 2. So that's dimethyl. And so we have dimethyl propane. Now, what carbons are they on? Well, if I start from this side, it's on carbon 2. If I start 1, 2, it's on carbon 2. They're both on carbon 2. When you see di, you need 2 numbers. Therefore, even if they're on the same carbon, you have to have 2,2 dimethyl. Because if I just put 1 number there, 2, where's the other carbon? I don't know. I have to guess. So that's how you do it. How's everybody doing so far? Hopefully I haven't given you a headache today yet, or ever. I see and Julio, if I'm pronouncing your name correctly, not, make sure I correct it. That's part of learning. And this was a tough example. And you have nothing to be sorry for. You tried it and you're learning from that. That's what I've learned in my life. You learn from what you do right and you learn from what you don't do right. All right, let's get back. All right, now, in organic chemistry, there are 2 nomenclature skills you should have, which means there's also 2 types of questions I can ask on the test for nomenclature. One is, here's the structure, give the Iupac name. The other one, which is this important, here's the name, draw the structure. So how do we do that? Well, let's take a look. Oh, by the way, as you know, I've said, there's no such thing as a dumb question. And if you ever don't understand one word I write on a whiteboard, you can ask, what the heck is that? Since we're almost time for the break, how do you do that? Well, you learn that table, propane, how many carbons? 3. And you know there's 4 bonds to carbon. This one has 1, 4 minus 1, 3 hydrogens. This one has 2 bonds. I have 4 minus 2, 2. This one, 1. And I'm done. And it's time for our break. Let's take a 5-minute break. I can get up and do some stretching. That's good for my legs so they don't cramp up. And I'll see you in 5 minutes at 1:55. I shut off my microphone. Let's start again. Hi, everybody. Well, I'll do that once in a while. But anyways, can you hear me now? All right.
Yes.
Thank you for letting me know. All right. When a couple of years ago, more than a couple of years ago, I started seeing my chemistry classes, students who were suffering from test anxiety. When they took a test, they know the material before the test. How did I know that? They come into my office hours asking for help or just checking. But when they took the test, they just, whoa, what's going on here? I realized they got real nervous during the test and their brain didn't function well then, which is not good. And I came up with a method that eliminates test anxiety like that. And those students who are used to getting C's, D's, and F's on tests, even though they studied, now, once they learned my method, their grades were A's and B's. I had a couple of Chem 170 students who were doing badly, flunked the first test, and then went on to get A's and B's. It really helped them. Also works for other classes too. And after a while, I realized, why do I wait until after the first test to tell students this? So next week, not this week, but next Wednesday, after class, or I'll end up about a little early, I'm ending being the official lecture and lab, I will teach my method how to eliminate test anxiety for any of you who want to. It takes about 15 minutes for me to go through my presentation, and it works quite well. So that'll be next Wednesday. All right, let's get back to what we're talking about. And that is a skill which is, given an Iupac name, you should know how to draw the structure. Let's do another one. And here's the name, 3-methyl nonane. Now, how do you do this? Watch closely. When you have an organic chemical name, organic name, you always start from the right and move left. You always start from the right and move left. And the first thing I see is nonane. So if I look at the table, which hopefully you will memorize this weekend, nonane is 9 carbons. So I can immediately put in 9 carbons. And I found it's better to leave the hydrogens to last. Next, I see methyl, and hopefully you've learned this table. Let's get started on this weekend, hint, or even today or tomorrow. Methyl is CH3 attached to something. That's what that line means. So where is that methyl group? And again, I keep on moving this way. It's on carbon 3. So I'm going to start 1, 2, 3, put my methyl group, and now I know there are 4 bonds to carbon. That's an ugly looking carbon, sorry. And that's how you draw it. Now wait, there's another way you can draw it. Really? Yes. This is 9 carbons. I'm going to start from this end. 1, 2, 3. And carbon 3 is my methyl groups, 1 carbon. And now I'll put in my hydrogens. Remember, there's 4 bonds to carbon. And there you have. And let's call this Roman numeral 1 and Roman numeral 2. If you still, those of you know Roman numerals, I've learned from my other class, not all students have been taught that. Which is the correct structure? And the answer is they both are. Wait a second. How can they both be the correct structures? What do you see here? My right hand. Now, if I asked you to close your eyes, and you did, and while your eyes were closed, I went like this. Oh, look, something new. No, that's not something new. You just rotated your right hand. Well, guess what? Molecules like this pen or your hand rotate in 3 dimensions. They're not glued to a piece of paper. So either one of those, and there are actually other ways I could have drawn it too, but most of you would do one of those two, would be correct. And good news, I have a piece of paper signed by the Board of Regents of Michigan State University saying, I understand that, my PhD diploma. And therefore, you can do either one. Now, on an answer key, depending on what it is, the alkanes, I'll start like most of you from the left. Now, later on in the semester, I just have a habit, and good habits, Dr. White doesn't change. I'll start counting from the right. And you can do either one, will always be correct on my test. So on a test, you could have written this either way. And now it's your turn. Why don't you draw the structure for 2-methyl propane? I'll give you a hint. Propane, 3. I think by now you might have gotten the hang of what's a methyl group. And don't forget, there's 4 bonds to carbon. And when you're done, give me a thumbs up. I forgot to do it. I was busy last night and this morning, but I'll have a poll set up by next Monday, so I don't have to do thumbs up. All right, I think everybody's done. Let's get to work. How do you decode the secret name to find out what's the structure? You always, for all organic molecules names, start from the right and move left. Propane. And hopefully you will learn this table. Hint, propane, 3 carbons. So now, 1, 2, 3, 3 carbons. Next, I have a methyl group, and that's CH3 as we've done before, and that's on carbon 2, because I'm moving this way. Well, if I start this way, 1, 2, 3, this is carbon 2. If I start this way, 1, 2, it's still carbon 2. And I'll put my methyl group, and I'll put in my hydrogens. So I know there are 4 bonds to carbon. Let's look at this carbon number 2 right here. How many bonds do you see? 1, 2, 3. 4 bonds to carbon minus 3 equals 1, means there's 1 hydrogen. And that's how you do it. Now, I don't know if it's a rule or it's just all organic chemists, somebody decided to do it. And we usually put, if we can, the alkyl groups below the main chain. See how this is below? But if you were to do this, that would be perfectly correct on the test. I'd look at it and say, oh, that's different, but it's correct. And it's sort of the same way. Here's my left hand. If I go like this, the thumb, think of it as a methyl group. Is that something different? No. By the way, that's my undergraduate college ring from Illinois Technology a long time ago. All right. Oh, let me do one more, just so you can see how it's done. And the question would be, draw the structure for 5-isopropyl, 5. Oh, wait a minute. Sorry, I was thinking of something else. Once in a while, my mind burps. That would be 5-isopropyl, 5-decane. And I'll do this one. You start from the right, move left. So the first, we come to decane. And what's decane? Well, if you haven't learned it, decane is 10 carbons. So, time to draw 10 carbons. Now, next I have an isopropyl group. Ooh, what's that? We haven't talked about that. So let's go to the alkyl groups. And notice they're 2 3-carbon propyl. N-propyl to the N carbon, isopropyl, 3 carbons. And the center carbon here is bonded to the chain, or later on, we'll do rings today. And now I can start from this end, 1, 2, 3, 4, 5, or I can start from this end, 1, 2, 3, 4, 5. And either way will give the same answer in terms of the structure. Let's start this as 1. Let's call this one 5. Isopropyl, 3 carbons, like that. Now, sometimes you'll see me draw an isopropyl like this and upside down Y. Either way is correct. And now we know there are 4 bonds to carbon. And there's your structure. And while you're copying that down, I will, that's a pretty molecule. Now you know he's an organic chemist. And remember, the longest chain, 1 to 10 decade. Now, if you're not sure, if you count other chains, you'll find that is the longest chain right here. Now, a sort of a pro tip that might help you out. By the time I finished my PhD degree at Michigan State, I had taken more tests than I ever wanted to take. And one of the things I found, I think it was mainly undergrad, I came about this. I found if you let the paper do the thinking, you get a better score. I did. How do you make paper think? Well, you keep more things in the paper than in your brain. How do you do that? Notice here how I wrote the numbers to help me. You can do it in your mind, not write them. But I've seen students say, oh, I'll put it on 5, and they'll put it on this carbon right here. For some reason, under stress, they pick the wrong carbon. But if you put numbers down, it helps you. Also, when you're determining, like I did over here, what's the longest chain, and the way I circle it, you don't have to do that. But if you want to, if it helps you, do it. All right, now we've done alkyl groups. I'm going to hold off on the halogens, chlorine, bromine, iodine, and fluorine until we get into later on, when we'll do it. We've talked about the methyl, the alkyl groups, methyl, ethyl, and propyl, isopropyl. If you're reading a book, it's in here, don't. It used to be when I taught face-to-face, I'd write those on a whiteboard. I see one of you are working in front of a big whiteboard. But anyways, now a number of years ago, I said, you know something, I'll make up the 2 files with name and methyl ethyl and the alkyl groups. Now the halogens, let's hold off for now. Wait, so know those. Let's now move on to cycloalkanes. Those are rings, and there's similar nomenclature for that than the alkanes. However, the ring portion serves as the base name, but you have to put the prefix, something that goes in front of a name. Cyclo is used to indicate the presence of a ring. So let's take a look at this. Again, this is not the most exciting part of organic chemistry, but it's an important foundation I have to help you build. Here we have a ring. Remember, we use the line method. Each bend in a line is a carbon. I'll draw them in now to show you. How many are there? How many bends? 1, 2, 3, 4, 5. Now what you do, and this is why it's important to learn that table, the ring is its root name. What's 5 carbons? Pentane. 5 carbons, pentane. But this is a ring, not a straight chain, so we use the prefix. It's cyclopentane. Now, big mistake students make on test number 1, they forget to put the cyclo in there. If you just put down pentane, I mark it wrong, because that's the same as if I ask, what's this, or what's this? This is my nose, this is my hand. They're different. Well, cyclopentane and pentane, in my mind, an organic chemist, this is different. They are different. By the way, if your rings don't look good, and sometimes I have bad ring drawing days, don't worry, I usually can make it out. Now, the first question I would ask you, and let me try if I can get a better ring. I have software. That's better. Don't look. All right, how many carbons are in that ring? Your turn. All right, let's look. Every bend in a line is a carbon. 1, 2, 3, 4, 5, 6. So that's 6 carbons. How do we name that? Well, first you look at the chart, Iupac names for alkanes. What's 6? It's hexane. So that's part of the root name. So I'll write hexane, but it's a ring. So I used a prefix cyclohexane. And it's all one word if you were typing it. If you've got a space there like I do, I'm not going to take off. When I grade tests, this reminds me about my test. One, every question on my test, I will in lecture here discuss the concept behind that type of question at least twice, usually a lot more. Second of all, I'll give you an hour. You're going to be taking your test at home. And if we were face to face in a classroom, you'd have about 55 minutes. The way I write my test, if you've done the practice problems and study, my test should take you about 35, 40 minutes, even though I give you 55 minutes. So when you're at home, I'll give you an hour, actually a little longer. We'll get to that right before the first test. So you should have no trouble if you practice. And I also, when I grade, I don't sit there, oh, how can I take off points? No, I hope they're right, but if it's wrong and I mark it wrong, but I hope that I try and make sure, in organic, it's hard to give partial credit. It's just usually the right or wrong. All right, let me have you try one. First of all, how many carbons in that ring? No, it's not a triangle. This is organic chemistry. That's a ring. Hopefully I'll pick 3. And if you didn't learn this table, 3 carbons is what? Propane. And I'll let you finish the name. Boy, time flies when we're having fun with hydrocarbons. Well, the root name is propane. No, not really. It's a ring. And you use the prefix cyclo. If you forget that, it's wrong. Don't ask for partial credit. I'm telling you that up front. Now, there's one more ring that Mother Nature likes. That's 1, 2, 3, 4. 4 carbons, butane. Why don't you write down the name of that ring? And while you're doing that, let me check something real quick. And yes, I am recording this, so I'll be able to post by sometime tomorrow at the latest on my YouTube channel, the video for this. So if you want to go back and watch us again, you can. All right, 4 carbons, butane. It's a ring. Therefore, you used a prefix. It's cyclobutane. Now, you don't have to write this down, but I thought I'd show you something interesting. This ring has 1, 2, 3, 4, 5, 6, 7, 8 carbons. 8 carbons is octane. And you usually, and it's a ring, cycloalkane. Now, when I'm driving and I come to a certain sign, I think of cyclooctane. What? Look familiar? Whenever I come to a stop sign, I think of cyclooctane ring, because that's what the outline of the sign looks like to me. Now you know I'm an organic chemist. All right, now, what happens when you have a substituent on a ring? Now, we've done this. The ring portion serves as the base name, but the prefix cyclo is used to indicate the ring. Now, let's skip the next bullet and go to the bottom one. I should really, if only one substituent is present, then no number is given. This is important. When only one substituent is present, no number is needed. Dr. White loves six-membered rings, so is Mother Nature. So this is a six-membered ring. 1, 2, 3, 4, 5, 6. As hexane, it's a ring. It's cyclohexane. Rings are easier to show for alkanes with other alkyl groups other than methyl ethyl. And oh, what's the substituent called? Or alkyl group is how many carbons? Count the C's. 3. Notice the N carbon of 3 is attached to the ring. So what do? Well, you've learned this table, and notice 3 carbons. We have 2 possibilities. 3 carbons. 3 carbons, and the N carbon is attached to a ring or chain, or 3 carbons and a middle carbon. What do we have? The N carbon. So that's called N-propyl. So this would be N-propyl cyclohexane. And this N is always small case, because we'll learn later in the semester, capital M is used for, N is used for something else in nomenclature. Now, the question is, why don't you call that 1N-propyl? Well, what if I wrote this molecule? Would that have a different name? Because what if I call this 1, 2, 3? No, this would still be carbon 1. All I've done is rotated it, just like my hand. And these are both the same. So when you have only one substituent alkyl group, it never has a number. I better share the fun. What would be the Iupac name? The question is 3 points. Give the Iupac name for the following. Your turn. Unfortunately, I don't think I can do multiple screen shares on Zoom, which I could do in a classroom with a projector. So I'll help you out. 5 carbons, pentane. 2 carbons on the ring. Everybody see this right here? Ethyl. If you're done, give me a thumbs up. Well, I think everybody's done, so let's look at this. And the question is, what's the ring? How many carbons? Every bend in a line is a carbon, and that's 5. Pentane. It's a ring. Do not forget to put the prefix cyclo. It's cyclopentane. And then we have, this is called an ethyl group. And since there's only one on there, we call that ethyl cyclopentane. Oh, let's do another one. Now, first thing I'll ask you to think about is, and hold on, I've got a droopy bond. That's better. How many carbons are in the ring? No, that's not a square, just organic chemistry, that's a ring. And the answer is 4. And 4 is butane. Let's find out if I'm lying to you. Hopefully I'm not. And 4 carbons is butane. Now, next, if you look at the alkyl group, let's go back to that. How many carbons in the alkyl group here? And the answer is 4. And if we look at the table of the alkyl groups, you have 2 choices. 4 carbons, either N-butyl, 4 carbons in a straight chain, the N carbon attached, or tert, or in about a week or so, I'll become, like I am, a lazy organic chemist. We'll call it a T-butyl group. Dr. White loves T-butyl groups, isopropyl groups too. And 3 carbons to center carbon, that's center carbon, that's called a tert-butyl group. So 4 carbons, butane, this is a tert-butyl. I'll give you 22.7 seconds to come up with the name. And I'll throw in an extra 4 or 5. You're doing organic chemistry. Hopefully it's not too painful. I said it's Bad Humor Wednesday. All right, let's do this. The ring, butane, 4 carbons. Every bend in a line is a carbon. The root name, butane, but it's a ring, so it's cyclobutane. I have 1 substituent, 4 carbons, 3 methyl groups, CH3 to the center carbon, and that's called tert-butyl. So that'd be tert-butyl cyclobutane. I have a bad habit. You really shouldn't put a dash there, but if you do, I'm not going to take it off. And that's how you do it. All right, any questions so far? All right, let's continue on. Let's look at this one. 2 or more alkyl substituents or alkyl groups are named and numbered the same way as alkanes, except the alkyl group with the highest alphabetical priority is located at carbon 1. Ooh, what does that mean? Well, I'll have to show you. And good news, I'm not going to hold you to this rule because this can get into gray areas that I've even got to think about. And the question would be 3 points, give the Iupac name for the following. Well, the first thing is, oh, we've got a ring, and I'm still having a bad drawing day. Let me fix this up. That's better. And how many carbons in that ring? I'll let you figure that out first. Am I nice sharing all the fun? Don't answer that. 1, 2, 3, 4, 5, 6. And 6 is hexane. And it's a ring, don't forget, cyclohexane. Now, what do we have here? Here we have a methyl group. Here we have an ethyl group. Now, per Iupac, and I'm not going to hold you to this, and I'll show you how there's going to be multiple answers I'll accept on my test, but for real life, there's only one answer for the right name. Which is closer to the front of the alphabet, E or M? Hopefully you picked E. So this is going to be carbon 1. Now you number clockwise or counterclockwise to give the other substituents the lowest number. 2, 3. If I went clockwise, that'd be 1, 2, 3, 4, 5. Which is smaller, 3 or 5? Hopefully you all pick 3. So let's look how we put this together. Alphabetical, the E goes first. That's 1 ethyl, 3 methyl, cyclohexane. All right, everybody take a deep breath, let it out, take a deep breath, let it out, relax. The first time I learned this, my head was going, what's going on? I got it. And a couple of weeks from now, you'll go back and look at this and say, was I having a problem with that? But yes, you're new to it. Let's go through how I came up with this name. First of all, the ring is the base name, 6 carbons. Remember, we started counting from either one. This would have been carbon 6 if this is carbon 1, hexane. Next, it's a ring, cyclohexane. Once we have the ring spoken for, what's left over? CH3, CH2, CH3. What are those called? Well, hopefully, hint, you'll learn CH3 is a methyl group, CH3, CH2 is the ethyl group. Next, the group with the highest alphabetical priority, the one closest to the front of the alphabet, is number 1. So the ethyl is 1, and you number clockwise or counterclockwise to give the other substituents the lowest number. If we go counterclockwise, 1, 2, 3, this is on carbon 3. And let me clear up things. One, 2, 3. You want the other way, and that's how you come together. Now, remember I said I'm not going to hold you to nomenclature to the alphabetical rule, which means there are a couple different answers here. You could have put down 3-methyl first, then 1-ethyl cyclohexane. But what if you called this one 1? Even though this is not correct Iupac, I will accept it on my test, 2, 3. What if you called it 3-ethyl? One methyl cyclohexane. I would accept that on a test, even though Iupac would say, no, that's wrong. And you could also have the number switch, which I would accept. So on my test for this example, realistically, the first one is the totally correct one, but I would accept 4 different answers. Don't tell anybody I'm being nice. Shh. Your turn. What would be the Iupac name for that molecule? Now, how many carbons are in that ring? Then I'll tell you. And the answer is 5 carbons. And 5 carbons is pentane. But now I'll let you finish on your own. We've already done CH3 knows methyl, CH2, CH3 is ethyl, and you try now. And again, this is not the most exciting part of organic chemistry, but it's important for you to learn this, just like I had to learn it, to understand organic chemistry. How many of you remember when you first learned how to read in first grade? Did you have, I don't know about you, but I had the reading book, Dick and Jane. Did you have that? Where it said, and Spot is their dog. And when you started learning how to say words and put them together, it was sort of hard and it wasn't that exciting till later on. I love to read. You learned how to read and things got interesting. Well, this is the same way. All right, let's do this. 5-membered ring, pentane. It's a ring, cyclopentane. I have here an ethyl group, and on a test, you don't have to write this, but I'm doing it for your benefit. This is a methyl group. The one with the highest alphabetical priority is 1. If you go clockwise, this will be on 2. If you went the other way, this would be carbon 5, and 2 is smaller. So it's 1-ethyl, 2-methyl, cyclopentane. Now, if you had written 2-methyl, 1-ethyl, put this first, I'd give you it right. If you got the number switch, 1-methyl, 2-ethyl, I would count that correct also, even though this is the only correct Iupac name. Now, don't forget, if you have 2 of the same group, we call that di. And here's another one for you to have fun with. And the question is, give the Iupac name for the following. 6 carbons, I just gave it away, hexane. And when you're done, give me a thumbs up. Starting Monday, I'll send out a poll where you can click yes or no. And I see the thumbs up are coming in, the votes are coming in. So I better get to work. The longest number of carbons in this chain ring are 6, hexane. It's a ring. Don't forget to put cyclo, or you'll get it all wrong. And then I have 1, 2 CH3 methyl groups. 2 is di. Since they're both the same, this would be 1, this would be 2. I could call this 1 and that 2. And when you have di, you need 2 numbers. And this would be 1, 2 dimethyl cyclohexane. Any questions so far? Guess what? It's time to take a break again. Come back in 5 minutes and we'll continue on. I can get up and do some more stretching. It's good for my body. I'll see you at 2:50. Time to get going. Everybody back? Hope you are. All right, let's get going. And let me remind you, tonight from 5 to 6:15, if you have any questions, feel free to come by my office hour. It's a different Zoom login. It's on the first page of D2L Chem 170. It's also in my syllabus, which is available also for you to download from Chem D2L that's desired to learn from ECC. So make sure that if you have any questions, you come to my office hour. All right, let's take a look. My mic is on, I checked. Let me do one thing real quick. I'm recording, so we're all set to go. There's two skills you should have in nomenclature. One, here is the structure, give the Iupac name. The other is, here is the name, draw the structure. I haven't done this yet today because I think everybody's with me, but just to be on the safe side, give me a thumbs up if you can see, draw the structure for a cyclopentane. Thank you, Trevor. It's always good. Sometimes Zoom tells me you should see it and you don't. So let's take a look at this. How do we do that? Well, you look at, and thank you, Jacqueline, too, the name, and you always start from the right, move left. Pentane, 5 carbons, but ooh, cyclopentane. And that's a ring with 5 carbons. And there I have it. Now, if you want to draw the carbons, you can. I wouldn't, it's more work. Let's do another one. All right. And here we have N-butyl cyclohexane. I'll do this one, but I will share so you can have some fun too. And what do? Always with an organic chemical name, when you're trying to decode it, to draw the structure, you start from the right and move left. Hexane, oh, 6 carbons. Cyclohexane, 6 carbons in a ring, 6-sided. Then I have, ooh, butyl, 4 N-butyl. In case you haven't learned it, let's take a look. N-butyl, right here, 4 carbons, 1, 2, 3, 4, and the N carbon is bonded to the ring or chain. So I need to put an N-butyl group on that ring. So I could put it here. I could have also drawn the carbons on this side going this direction because there's free rotation around a carbon-carbon bond. And now put in the hydrogens. Now, interesting thing about a ring is they rotate. You could have just as easily drawn this. The same molecule all I've done is rotated. And you could draw many others. They're all correct, and Dr. White, me, knows how to interpret that. All right, your turn. Why don't you draw methyl cyclohexane? I see a question, so I better go check it out. Julio, I'm not sure. Let me write something on the board, on the whiteboard. Do you mean, and let's go down here for the time being. Is this something like you mean, either like this or this? And all right, that's a very good question. Everybody pay attention. How many bonds to carbon? 4, 4, 4 bonds to carbon. Whenever you draw a structure, make sure carbon has 4. Oops, let me fix this figure. 4 bonds to carbon. If it doesn't, it's wrong. So let's take a look at the two structures I draw. Let's call them A and B. Original, isn't that? Notice on my N-butyl group, each carbon has 4 bonds. Let's look at B. Look at this carbon. How many bonds to it? 1, 2, plus 3 hydrogens. That's 5 bonds. It's wrong. See, it even says on your screen. Now let's look at this carbon. It's got 1 bond there, plus 2, 3 bonds to carbon. And that also is wrong. So the answer to your question is yes, it does matter which carbon has the 3 hydrogens and which have 2. So which one you connect it to is important. And does that answer your question? And by the way, first of all, thank you for your question. That's a very important question. Students make that kind of mistake on test 1, and I mark it wrong. And now you know not to do that. And a number of your classmates know that too, which is a good thing. Thank you. And now you know when I really say it, I really practice it, there's no such thing as a dumb question. And let's go back to here. Let me rewrite it. And now, why don't you draw methyl cyclohexane? And good news, I typed my test, so this L, you would know is an L. I don't handwrite it. That would be cruel, unusual punishment. I think the Supreme Court still has outlawed that cruel, unusual punishment to students. And give me a thumbs up if you're done. Thank you, Trevor. And everybody else is popping up. All right, let's do this. How do you decode the secret code to draw the structure, the Iupac name. Remember, Iupac means the official name, even though I like to say it, International Union Pure Applied Chemistry. I just think it sounds cool. I'm a chemist, or organic chemist. Excuse me. Start from the right, move left. Hexane, 6 carbons. Cyclohexane, 6 carbons in a ring. Methyl group, CH3. I could have put it there if you wanted to. You could have put it there, and all I'm doing is rotating the ring around whichever direction you want to go. All right, let's continue on with nomenclature. And here we have 1-tert-butyl 4-methyl cyclohexane. I'll do this one, then I'll let you have one too. And how do we decode this to know what to draw? We start from the right and move left. I should warn you, a couple weeks from now, you'll be having nightmares. Either I'm saying, how many bonds to carbon 4? Or how do you decode this? You start from the right and move left. I hope you don't have any nightmares. That would be awful, hearing me say 4 bonds to carbon. But you do start from the right, move left. Hexane, cyclohexane, that's this ring. And then on carbon 4, I have a methyl, and carbon 1, I have a tert-butyl group. Now, hopefully you've learned this chart. This is a tert-butyl or T-butyl group. And this is your old friend, the methyl group, or soon to be your old friend, the methyl group. Remember, tert-butyl, 3 carbons to center carbon. The center carbon is bonded to a ring or chain. In this case, we're talking about a ring. Now, I can make any carbon 1, but most of you, so I'm going to do it this way, will do this. Remember, there's 4 bonds to carbon. This is carbon 1, and the methyl group is on carbon 4. And whether you go clockwise or counterclockwise, this is carbon 4. And there's a methyl group, CH3. Let me draw it over here. Didn't do much better. That methyl CH3 on the top. Let's try once more down here. And the same thing, I can have a problem on a whiteboard in a classroom. And that's how you do it. And I promised you'd have one to try. So let's do this. And that's 1-ethyl, 2-methyl cyclopentane. Now, I'll help you out. Pentane 5. Your turn. Have fun. And when you're done, give me a thumbs up. So a lot of people are, but take your time. I try and give everybody time to finish. Finish. All right, I think everybody's done. Let's do this. How do you decode the name? Again, the question is draw the structure for the following Iupac name. You start here and you say, oh, pentane, 5 carbons, cyclopentane, it's a ring. And that's not a cyclopentane ring. I got cyclohexane on the brain. Let me get it off. 5 carbons would be this. Then on carbon 2, I have a methyl group, carbon 1, ethyl. Ethyl, CH2, CH3 like this. And remember, it matters which carbon is a CH3, because this carbon has 4 bonds to it, and this carbon has 4 bonds to it. This is carbon 1, either this carbon or this carbon. I can call 2. Most of you are going to go clockwise. So this would be the structure. You could have also done other ones. None of you would have done this. I might have. This is 1 ethyl, 2 methyl, cyclopentane. And oh, let's do one more. And there you go. It's 1,1-dimethyl cyclohexane. Have fun, draw the structure. Hopefully you know now hexane 6. And when you're done, give me a thumbs up, please. Next week, I'll send out a poll. Remember, if you're having problems, always feel free to ask for help. All right, I think everybody's done, so I better get to work. How do you decode this? You start from the right and move left. Hexane, 6 carbons. Cyclohexane, a ring. And then methyl, well, that's CH3. Ooh, di, that means 2. And they're both on carbon 1. I'm going to call this 1. And that's how you do it. You could have also done this. And that's how you do it. Good news. I don't know. I haven't looked at the TV for this weekend. But if you go to any football parties, you can teach people all about rings and alkanes. Not People don't want to hear organic chemistry at football parties. Trust me, I know. Uh-oh, once in a while, I have a problem with Microsoft Word when I'm using Zoom, and I just have that problem right now. Hang on. All right, we're back on board. Sorry about that. That happens. I lose some data on my whiteboard, but I don't save that anyways. All right. Sorry about that, but I haven't figured out how to stop that. But I think because I have so many things running on this PC, which is a good one, that happens. All right, let's move on. Now, the switch, will this be on a test? Click, turning it to the off position. But I thought I'd teach you something interesting about alkanes. There's an important physical property, that's the boiling points. That's the temperature at which something boils. You're all familiar with boiling water. Now, the boiling point of alkanes raised as the chain length increases. More carbons, the higher molecular weight, the higher the boiling point. Now, the boiling point falls as you have more branching, or it becomes more spherical. An example would be this will never be on a test or a final, mind, and you have my word on that. But this straight chain, let's call it A pentane, which would be pentane. This is 2,2-dimethylpropane, B. This has a higher boiling point than this. If I had octane, octane has a higher boiling point than pentane. There's something interesting I thought I'd let you know. Now, there's things called conformations. I'm going to skip this. I thought I took this slide out. Now, let's talk about, first of all, organic chemistry. Over the next number of weeks throughout the most of the semester, I'm going to be talking about what's called functional groups. Functional groups are a collection of atoms in an organic molecule that always undergo the same type of reactions under certain conditions. Just like if you look right over here, I have a door in my home. And I know I can go use a door to go from this room, my office, into the hallway to other places. If you were at ECC, I'd be pointing out the door to get in building M, or if we were having classes, is different from the door to get in my classroom, but you know the function of a door. Same thing, I'm sitting on my office chair, which may be different from the chair you're sitting on, or if you go into your, say, dining room or somebody else's dining room, you have dining room chairs are surely going to be different than my office chair. But you know the function of a chair. One of them is to sit on. The other one, which you shouldn't use, is use it as ladder. Don't, dangerous. I don't. But anyways, we're going to be learning about functional groups. Now, technically, alkanes are not really a functional group, but I'll sort of put it together and talk about it like it was, but it's truly not a functional group. And a good part of this semester, you're going to be learning chemical reactions of specific functional groups. And these are the building blocks organic chemists use to make molecules that you use in your daily life. Do you like the soap you use to clean your hands? That's made, and understanding functional groups, and I'll teach you later on how soap is made. Also, I've worked in the industry. Do you like fabric softener? It makes your fabric of your clothing feel real good. Well, that's a specific molecule called a quaternary ammonium salt that I'll teach you about later on. And how you make that is using certain functional group chemistry. So the functional group chemistry I'm going to teach you is just like, say, a carpenter learns how to use wood, like a 2x4, 1x2, nails, screws, bolts, to build things like my house, which has wood in it, and a carpenter built it. So let's look at our first organic reaction, and that's called combustion of alkanes. And I could have put not and, or cycloalkanes. If you react it with oxygen with a little spark or heat source, you get carbon dioxide, water, and heat. And that happens in your furnace, your house. That also happens in, right now, my car. And if you light a candle too, that happens. Now, this is a general reaction. And let me write it another way, because you don't need to know the empirical formula. Any alkane or cycloalkane plus oxygen. And generally, I'm interested in the chemicals, not the heat, even though that's the most important thing of this reaction in our life, is carbon dioxide and water. And this is called the general reaction. And a general reaction is like a road map or GPS. If you're here, wherever you're living, let's assume we are all in our classroom in Elgin. And I said, you've got to go to, and I've been there, Timbuktu in California. And there is actually a Timbuktu outside of LA, Los Angeles. How do you get there? Well, if you didn't have a map or GPS, what's the likelihood you'll get there in a reasonable amount of time? 0. You won't get there. But if you have a map or GPS, well, I'm starting at Elgin, or I'm in Schaumburg, or wherever you live, you're going to go west and you can see the highways that will get you there. Well, a general reaction that I just showed you is the same thing that will help you determine what product or products you make. And if you don't know those, you're going to lose a lot of points. Test number 1, 50 points. Test 2 and 3 and 4, roughly about 60 points, and about 60% of the points on the final exam. So you've got to memorize them. How do you do that? You write them down and say them 5 times. As I mentioned the other day, I had a student after the first test who didn't do well and said, how do I do well on my test? I said, did you write things down and memorize them and learn them by writing and saying them 5 times? And that student, she said, that's a lot of work. And her friend was standing right next to her, got an A on the test and said, yeah, but I got an A. And the student got the message. So let's look how we do this. Now, before we do this, I just realized I didn't do anything. Quick review. This is a chemical reaction. On the base of the arrows, those people work in academics call this the reactants, A and B. I've worked in industry and we call those the starting materials. More likely than not, I'm going to call them the starting materials. At the head of an arrow of the chemical reaction, C is called the product. If there's more than one thing, those are the products. And that's why I put the S in brackets. So when we come up to this problem, the question is give or write the product or products for, and A would be this reaction right here. Remember, A and B are the reactants or starting materials. What you make at the head of the arrow are the product or products. So how do you do that? Let me clean this up down here. We look at that and say, oh, guess what that is? We don't have to guess, hopefully you know. That's an alkane, propane. But it could have been a cycloalkane. And you're reacting it with oxygen, and you learn that what are the products, and heat, I don't call it product, the actual chemicals, carbon dioxide plus water. So if I take an alkane, propane, your barbecue, react with oxygen, excuse me, ooh, it's time for some water, hold on. You get carbon dioxide plus water. Now, I have a special gift for you. Whoops, there we go. Organic chemists are lazy. We are. And we don't like balancing equations unless we have to, chemical equations. In my class this semester, you will never, ever have to balance an equation. Yay, that just made your life a lot easier. That's why I call it a gift. And we don't. The only time we balance equations, you've had general chemistry, which I think everybody here has, even though I did do some waivers, but you had high school chemistry. Then you have to do that and use that to determine how much of each compound weight-wise, which industrial chemists call the charge weights, you have to use. And I've done those calculations. when I was in industry writing what we call procedures for a chemical plant, I've had procedures where I've done calculations where the final amount of all the starting materials you add together, we're talking about close to 180,000 pounds. At $1 a pound, that's a lot of money. You don't make mistakes or you get fired. And I never got fired for that. Well, something else, but that's another story. So I'm done. The answer for this problem A is carbon dioxide and water. And why don't you try B? What would be the product or products for the following reaction? And when you're done, give me a thumbs up. I think a lot of you, I'll give you another 25.7 seconds. Go. All right, let's do this. What's this? This is butane, but I'll never ask you in this type of problem, give the name and then do the reaction. That's cruel, unusual punishment. I don't do that. But notice this has only carbon, hydrogen atoms, only carbon, single bonds, and that's an alkane. Could have been a cycloalkane. And I'm reacting with oxygen. And you learned this general reaction. When I have this and this, what do I get? Carbon dioxide plus water. And that's the beauty of organic chemistry and functional group, is certain type of molecule always reacts the same. So the answer here is CO2 plus water. Oh, let's do one more. I should warn you, organic chemists can bend the arrow when we're running out of space. And it's the same thing as a straight arrow. And the question would be, give the organic, not the organic, give the product or products for the following reaction. 3 points each. Your turn. And when you're done, give me a thumbs up, please. You're doing organic chemistry. Hopefully it's not that painful. All right, I think everybody's done. If we look at C, by the way, you don't have to know this, but I'll tell you this. This is an octane. And only carbon and hydrogens and carbon-carbon single bonds. And that's an alkane. It could have been a cycloalkane. It's not. And when I react it with oxygen, what do I get? Carbon dioxide plus water. And therefore, what will this give you? Carbon dioxide and water. And that would be the answer. Now, a couple important things I like to mention. Notice under each one of these, I wrote the general reaction. Some of the top best students I've ever had in organic chemistry, Chem 170, you looked at their test or final, under each one of these type of questions, they would write the general reaction. Also, as over the years when I've taught Chem 170, some of my very top students, if you look at their exams, they never write the general reaction underneath. I always will, because this is going to help you learn this. But you do or don't have to, that's up to you. But they've all learned these general reactions and how to apply them. Because I'm never going to ask you on a test, give the general reaction for an alkane reacting with oxygen. I'm going to give you specific examples like this. Now, let's talk about C. A major constituent of gasoline, about half the weight, are alkanes, different ones, and a predominant is octane and isomers of octane. So when that burns gasoline in your car engine, coming out the tailpipe, if it's doing its job correctly, you get carbon dioxide and water, CO2 and water. How many of you ever in this super cold weather like we have now, you pull up to a light or a stop sign and you look at the car in front of you and you see coming out of the tailpipe liquid. And you say, oh no, gasoline's leaking from that car, it's going to explode. No, the tailpipe and muffler are still very cold. And normally coming out of the gasoline through the muffler and tailpipe is very hot water, and it's a gas, you can't see it. But when it's cold and they just started out like in this weather, the cold muffler and the tailpipe condenses the water vapor, the gas, water is a gas coming from their car engine because it's very hot, to a liquid. And that's the liquid you're seeing coming out of the tailpipe. It's not going to blow up. Now, here's a secret. A favorite trick on a test, chemical instructors, is put a big, scary molecule. If you don't know general reactions and how to look at a molecule, you go eek. Hopefully you never go eek and you get the wrong answer because I scared you with a big, scary molecule. But if you know what you're doing, you shouldn't be. Let's take a look at the same reaction. And there, what do we have? A big, scary molecule. Oh no, what do I do? I look at that and I say, it's only carbon and hydrogens and carbon-carbon single bonds. So that's just an alkane. Or it could have been, but it's not, cycloalkane. And when I react it with oxygen, I know I get CO2 and water, don't have to balance it. So this gives me CO2 and water. But if you didn't know that this was an alkane, you look at that and say, oh my goodness, what do I do? Well, that's where it helps to understand what are you looking at the molecules and what type they are. All right, now I don't have a slide for this, so I'll put it on the whiteboard. And this is important. What are some examples of alkanes in our daily life? One of the things I do in this class is I show you how this applies to your daily life. That makes it more exciting. Well, one example would be methane, natural gas, CH4, and that you use to cook with, heat your house, and heat your water here in Northern Illinois. Another one, propane, that's for your barbecue. And let's think about another one. Gasoline, more carbons, 8 carbons or not. And that's also alkanes, contains half of that. By the way, next time you're out driving around and you pass a gas station, remember half the way to gas they're buying there, somebody's buying there, are alkanes. So don't forget they're selling alkanes. It won't hurt you to think about organic chemistry when you're not in my class. Now, if we get the molecule with alkane with more carbons, that's baby oil. That's an alkane. If you have much more carbons, and I'll use a trade name, Vaseline. If you have a lot more, you can have, let's see, paraffin wax. Now, 50% of good candles are made with paraffin wax, which is a lot of hydrocarbon, real big change. Now, one of the things I learned, I hadn't thought about, and then later on I learned more about it, and I thought baby oil, just like gasoline, is flammable. So is Vaseline. And I remember when I taught this in a Chem 170 class, one of my students was a neonatal nurse who was going to get her master's, need to take organic again, and warned everybody, warned new parents, they use baby oil, don't smoke around your baby, which you shouldn't do anyways, and don't have any candles around because it's flammable. All right, if I look at the clock, I'm just about out of time. Quick thing, next Wednesday, a week from today, I will go through problem set 1, or the alkanes problem set. It's not called problem set, the alkanes problem set. I would highly recommend between now and next Wednesday, you do that. It has all the things we've done so far, and I don't expect you to hand any that in, but if you want to do good on the test, practice, and that's your chance to practice. After test number 1, you'll understand, wink, wink, hint, hint, say no more, That comes from Monty Python Flying Circus. That why I call them practice problems. With that, oh, I went a whole 60 seconds over. With that, I'm done today. Don't forget, I have my office hour tonight from 5 to 6:15. I'll see you next Monday. With that, I'll say bye, gehen gesund, which is Yiddish for going hell. And under the pandemic, I like to say that. So gehen gesund. Bye now. I'll see you on Monday.